welcome to episode 2 of the Building Performance Interactive. We're really excited to have you all here. We are going to be joined by Lawrence Taylor from KTF Timber Frame, and we're going to be talking about offsite timber frame construction from start to finish. So my name is Zach Semke, and I'm director of House Accelerator. And a big hearty welcome to everyone for joining us, whether you're in the UK, Ireland, Europe, North America, and parts in between or around. So thanks again. So I want to give a big thank you also to the co-creators of the Building Performance Interactive, Yulia Potor and Hugh Risky. So Yulia, would you like to say hello?
That's great. Thank you very much, Zach. Hi, everyone. Right. I'm Yulia Potor, marketing manager of Partel. We've dedicated months together with Accelerator in bringing this interactive program to life, thanks to all the remarkable people involved in this series. We hope that today's episode will impact and support offsite construction approaches in delivering high-performance buildings. Thanks, Zach.
Yeah, so my role today is going to be as Q&A concierge. So I will be, as questions occur to you during the program, please put them into chat, and I'll be tracking those questions in order. And when it comes time later in the program for our Q&A session, I'll be inviting people to come on camera if you feel comfortable and to ask the question of the guest, of our presenter, or of the co-host yourself. So that'll be my role. All right, so moving on to our co-hosts. We have 3 fantastic co-hosts: Ben Adam Smith of House Planning Help, Hugh Risky of Partel, and Mike Jacob of Kiss House. So with that, Mike, I think I'll let you take it away with a welcome.
Thank you, Zach. My name is Mike Jacob. I am a co-founder of a company called Kiss House, and we are in the process of bringing to market a repeatable, recognizable passive house housing product and innovating new product systems and materials alongside it. Very excited to be here today. Really looking forward to Lawrence's presentation. Thanks very much.
I'm Ben Adam Smith from House Planning Help website, and we've had a number of off-site construction companies who've been on the podcast before, and I've visited Makar and others as well. But for me, what's particularly interesting is the cost certainty side of things. I think that's fantastic. Just, taking things away from the weather, the elements, you can get on with the work. And I'm quite interested why there's still, well, certainly in England, a lot of resistance to off-site manufacturing, and it's been around for quite some time. So I'm looking forward to this. I've got lots of my own questions as well, but I'll hand you over to Hugh now.
Thanks, Ben. So yeah, I'm Hugh Risky, founder and technical director of Partel. We're a supplier to this industry. So I guess for me, the topic is really relevant. I actually started working in construction with offsite manufacturing more than 20 years ago, and that's mainly a big part of our work today. So we're delivering to offsite factories. I suppose I personally believe that the construction industry needs to pivot really quickly towards offsite construction, and that I suppose we hope that people start to see and acknowledge the benefits in accuracy, speed, carbon impact, safety, and I suppose a huge factor is the factory capacities, compared to today's labor issues. So that's really critical to delivering our new buildings. So all of that in mind, we're really delighted to welcome Lawrence Taylor of KTF to show us how they are helping achieve those key benefits. Lawrence has 19 years experience working in the timber frame industry. He's really comprehensive knowledge kind of from the start to the finish of any project. He's passionate about ensuring the client gets the home they'd always dreamt of, while using technology that will allow them to enjoy it for decades to come. His belief is to educate people that the methods are available today to build a house of tomorrow. Over to you, Lawrence.
Hey, thanks for that. Hello everyone, and welcome to our presentation on how off-site construction and timber frame and the significant role that it plays to maximise building performance. Okay, so the presentation today is going to focus on how timber frame construction, the process from the conception of the project right through to completion and all the stages in between. A little bit of background about myself, like you says. My name's Lawrence Taylor. I'm the Business Development Manager for KTF Housing UK, based in the northwest of England in Lancashire, and cover the entire of the UK. My career started in 2002, working as an office junior for a local timber frame company, and worked my way through the company, ending up as quality control manager, which saw me travel in the UK, attending sites and carrying out inspections to ensure the timber frame had been erected correctly. And I was then on hand to answer any queries that the client may have. It was a great way to get into the industry, having seen all the different parts of the office side of the business, then moving out onto site. I then ventured out and started my own business, but this was still very much with a timber frame focus. This would include supplying and erecting the timber frame element of a project, or taking it through all the way to completion. This featured building my own parents' home back in 2011, which I'm pleased to say they're still enjoying to this day, along with the reduced energy bills that they've been enjoying for the last 10 years. This brings us up to today, where I'm Business Development Manager for KTF, where I deal with each project from day one through to us completing the erection process on site and beyond. It's something that we pride ourselves on, that our service doesn't finish when we are finished on site. We are always on hand to help our clients in any way we can. Next is a brief bit of background about John Keenan, who is one of the founding members of Keenan Timber Frame. To date, he has played a major role in bringing KTF to where it is today. John began his 25-year career in construction on finishing college, where he was awarded a Bachelor of Science Honours degree in Quantity Surveying and Building Economics. He worked for 2 years for PJ Hegarty and Sons before founding Keenan Timber Frame with his father and brothers in 1999. This is a brief agenda about what we're going to go through today. So we've got the introduction of Keenan Timber Frame, our manufacturing process, our on-site installation process, the advantages of timber frame, and then there'll be a Q&A section at the end of the presentation, which I think is going to be hosted by Zach. So Keenan Timber Frame's process is very much a 4-stage process, first of which is the quotation stage. Then we go into design and engineering, then into manufacture, and then finally onto the delivery of the kit to site and assembly. The quotation. The customer has an initial meeting with us. We go through their plans and discuss the project in more detail. Our estimating department then compiles a detailed quotation for their project. It is at this stage where we focus in on what is important to the client to ensure the smallest details have been considered. The design. When the quote has been approved by the customer, the design team take the drawings and adapt them to suit our timber frame structure. Once this has been done, we issue a base plan drawing along with the point and line load calculations, which allows the client to progress their project to DPC level. It is at this stage we carry out a site survey to ensure the substructure is within tolerance to accept the timber frame. We then progress with the full design, ready for the next stage in the process. Manufacture. The design office sends the drawings to the automated machines in the factory. The frame will be manufactured to millimetre accuracy. We will show you a little bit more about the manufacturing process a little later in the presentation. The assembly. The frame is delivered to site and erected by one of our specialist erection teams. The frame will be ready to be made wind and watertight within as little as a week. Next up, we have a short video which is presented by John Keenan, talking through the manufacture and erection process in a bit more detail.
Hi everybody, my name is John Keenan from Keenan Timber Frame. We are based in Dundalk, County Louth in the Republic of Ireland. We have been manufacturing and delivering homes since 1999 and we were the first company in the Republic of Ireland to factory fit insulation and airtight membrane to all our panels. At the first stage of our process, we receive your drawings from your architect or engineer, and we adapt the design to a timber frame home. Once the designs have been agreed and engineered, we send them to our automated saws and lines. Our automated saw works within a 1 millimetre of tolerance. The timber we use comes from sustainable European forests. All our timber importers are either FSC or PEFC certified. Our software breaks down each home into floor panels and wall panels. Each component is numbered and clearly labelled so it can be traced through the manufacturing process. The next part of our process starts at the framing station, where each wall is automatically made by our automated line. We then move on to the next part of our process, where we fix OSB to the external face of the walls with our automated nailing bridge. It will fix the OSB using predetermined patterns specified by the engineer. The next part of the process, we attach the external breather membrane. We use EcoFoil EXO from Partel. Apart from the obvious performance of the material, we especially love the workability and the robustness of this product. Because the wall at this point is the wrong way up, we use our butterfly tables to safely turn the walls over and allow us to fit our external quilt insulation. We then fit a 50mm rigid PIR insulation to the inside face of the external wall, giving us a combined U value of 0.14. We then fit our airtight membrane. We use EcoFoil EZO from Partel. All reveals and openings on the panels are taped in the factory to ensure ultimate airtightness. We then fit a 35 by 50mm service batten to the wall panels. This allows all services on the walls and protects the airtight barrier behind it. All the wall panels are then stacked carefully. Each batch is loaded on the trailer in sequence. Last on is the first wall panels needed on the on-site erection sequence. The kit arrives on the job site. We then fix our sole plates in accordance with the engineer's requirements, making sure all DPCs are attached properly. Our on-site erecting team then checks all dimensions and diagonals to make sure the base is in accordance with the base drawing. Any structural steels are fixed in place to hold them plumb while the kit is lifted into position. The panels are then craned as per their batches into position on the base. All of the wall panels are then craned into position as per the erection sequence and drawings. As the external lift of walls happens and are fitted, we then fit all of our internal walls. Followed by our floor cassettes. Our floor cassettes are pre-assembled off-site in the factory. In KTF, we use our space choice system. This allows services to be easily installed and provides the client with a silent floor system, which can incorporate a lightweight structural screed if required. All our floors are typically done at a 400 centre, and our plywoods are glued and screwed. All our trusses and spandrels are made in the factory. We can custom make any roof truss or spandrel unit as per the client's design. KTF also have a suite of fire testing done on our walls, floors and trusses. Here are some of our recent projects.
So the next stage in the presentation is showing the benefits of timber frame. Timber frame is a fast and efficient off-site form of construction. Using timber frame will reduce construction time by approximately 30%, something that on a self-build project might not have as much of a cost benefit as you would see on a development project where you potentially have 10, 15 or 20 units. When you take into consideration the reduced prelims costs, it can have quite a dramatic effect on the overall financial implication. It can be constructed at a lower cost due to the fact that a timber frame is a lightweight structure with high load bearing capacity. Wood is the only renewable building material in the world. Wood has a natural ability to regulate temperature, moisture and sound. Timber frame has better heat retention, reduced energy demand, resulting in a fuel efficient dwelling. What we have here is a short time-lapse video of a project that's been recently done in Ireland. The house itself is 2,337 square feet. It's a bungalow and it has 3 bedrooms. From start to finish, the erection process took just over 5 days. Some of the key features of timber frame, again, is the NZ, nearly zero building energy buildings. Any building completed after the 31st of December 2020 must achieve the NZ standard. These are changes to the ventilation and energy efficiency requirements of new and existing houses. At KTF, we understand air tightness, continuous insulation, thermal bridging and controlled ventilation. We know it is not just the energy efficiency of a building or low energy buildings that should be considered. It is equally important to provide quality, comfortable, healthy buildings for our customers. Thermal bridging. Thermal bridging or cold bridging occurs when there is a break in or penetration of the building envelope, resulting in a difference of temperature. For a home to be energy efficient, it must be well insulated and as airtight as possible. This is something that whenever I'm speaking to clients, I always use the analogy of a really nice warm jacket. You wouldn't have a nice warm jacket and then leave the zip open. It's a pretty simple analogy, but it seems to come across quite well. Because a KTF timber frame home has an excellent standard insulation, it can reduce dramatically the amount of thermal bridging through the superior thermal envelope and also improve air tightness in the building. Air tightness. Air tightness is the control of the flow of air into and out of a building. Air tightness is absolutely essential in maximising the effectiveness of thermal efficiency. Ensuring vast savings over a lifetime, it is a critical component in any type of low or zero energy building project to have less than 1 air change per hour. Building energy rating. Building energy rating is an indicator of the energy performance of a building. All new homes require a BER rating. KTF uses a high quality efficiency insulation products which helps us achieve an A3 building energy ratings for all our homes. Carbon footprint. Wood is effectively a carbon neutral material, even allowing for transport. All timber used in a All timber used in a KTF house is from sustainable sources. A timber frame house has the lowest CO2 cost of any commercially available building material. For every cubic metre of wood used instead of other building materials, 0.8 tonnes of CO2 emissions are avoided. Passive house. Passive house homes and buildings offer superior indoor comfort due to consistent temperatures and good air quality. They also have the added benefit of reducing both external and internal noise due to the high levels of insulation. A KTF timber frame home is an excellent solution for a passive house. There's a little bit more detail about our panel system itself. So we class it as a future frame closed panel system. It's our most popular system. With this system, panels come to site pre-insulated with mineral wool in the stud cavity, a 50mm PIR sheet insulation, internal airtight membrane factory fitted and completed with a 35mm service pattern. This wool system has a U value of 0.14. The superior thermal envelope ensures fantastic thermal performance and airtightness. So we now have a short CGI, so I'll pause it a couple of times just to illustrate what all the different sections are. So all the timber frame is assembled using a 140 by 38 CLS timber. On the external face of the timber frame, we've got a 9mm oriented strand board, followed by the Partel XO external foil membrane. We then have a tape stud indicator. This is there to assist with external cladding. Internally, we then fill the cavity with 140mm mineral wool. And as mentioned, a 50mm PIR board on the inside face to prevent any cold bridging. This is then covered with an airtight membrane from Partel. And finished with a 35mm service pattern. And as you can see here, this then allows for any external facade, be it blockwork, brickwork or timber cladding, to be fitted. And there's just a brief section showing all the different elements of the build. Now what we have here is an example of a passive house that we've recently completed. As you can see, it's quite a tricky design, having the curved glue lamp sections. But one as a joiner, I would have loved to have been on site, been involved with, to be honest. So it took 2 weeks from start to finish to go from slab to being ready for wind and watertight. It's a 2,197 square foot property that has 5 bedrooms. There's just some more images of that one. Really nice project and one that we were extremely happy to be involved with. At the end of the presentation, I know that Zach will be leading the Q&A, so if anybody's had any questions about our panel system or what you've seen so far, feel free to drop it into the chat below. And we've got our contact details here. For any projects in the UK, you can contact myself on those details. And also any projects in Ireland or globally, you can get in touch with John Keenan. And we're more than happy to discuss your project. Just leaves me to thank Zach, Hugh and Mike for the invitation. Hope you've enjoyed the presentation. I'm looking forward to answering any questions you might have.
Thank you, Lawrence, very much indeed for that wonderful presentation. It's really great to see a company so committed to timber in particular and best practice timber construction at that. We're at a time of change in the industry, and there's a move towards offsite in terms of trying to address the housing crisis or housing shortage here in the UK. Timber, we know, only represents a relatively small percentage of the output at the moment, somewhere in the region of 20%. I'd be interested to see what you guys think about what we can do to try and increase that. You know, given these times, it'd be great to see timber kind of enter the mainstream. I don't know what you guys think about that, Hugh and Ben, but we're looking at 20% of timber offsite at the moment is meager, really, and it's certainly something that we're trying to encourage at this end at Kiss House. But there's really great commitment from you guys, Lawrence.
I think
Hugh, what are your thoughts?
I think, to be honest, it's probably people's preconceived ideas as to what timber frame is historically. I think you only have to look as far as places like America, Canada. They've obviously got well on board with it. Their climate, their sort of environment that they have is a bit more extreme over there. They got one extreme to the other. The UK, they're a little bit more stuck in the ways. They're used to bricks and mortar. So I think it will, with new regulations that are coming in, I think it will make timber frame more of an obvious choice. I still think brick and block will always have its place, but I think timber frame will become more of a key feature.
I'm going to jump in here because, you know, I'm as guilty as anyone in terms of I live in a brick and block house and knew full well that I could have had an offsite house. It's slightly unusual circumstances that I was quite keen to understand why in England masonry is such a common choice and the default, really. But then I am yet another number for a masonry, albeit a passive house. So if you are going to build masonry, you can get to passive house nice and easily if you keep the form of the building right and do all the usual things that we talk about. But yeah, there's definitely, I remember at one stage I was hoping to build a straw house, and at the back of my mind was this feeling, how on earth am I going to convince my dad that this is a good idea? So there is definitely some sort of friction against any new method of doing things, and it really helps when you've got examples, if you can go to people and then think, oh, actually this is all right.
Yeah, I think that's a huge thing, being able to show people examples of it. If they can physically see it, it tends to reassure them, whereas if they're just looking at literature, it doesn't give them that much confidence, especially if they're building their dream home. Having that ability to go and see the product, meet the company that are producing it, I think is key. At the end of the day, people buy from people, so they want to be able to meet that company and trust what they're saying. And like you say, being able to go to a site and see an actual example of that is quite a good way to do that and give people that confidence that they need.
Yeah, I think it's the perception of the material, the perception of timber as being a kind of, certainly in the UK, relatively unusual in comparison with bricks and mortar, but also the perception of prefab or off-site construction itself is something that people are still struggling with, aren't they, really?
Yeah,
I think that's right, Mike. I mean, the UK, it's quite interesting. It's got some form of off-site construction for over 100 years, and it's changed through the decades, from steel and concrete to those prefabs we talked about. And probably up until 2008, it accelerated, and probably the quality wasn't there, and that's probably influenced some people's ideas. But I think the presentation we've seen kind of shows that it's a very different thing, the modern timber frame offsite construction. It's something that is expected to have, more than higher, I suppose, more than 70% fewer defects on site. So we're dealing with things on a repeat basis in a factory that can kind of influence the conditions. We can't replicate those conditions on construction sites. The other kind of thing I wanted to talk about was just the sheer volume and how we managed to deliver those numbers that are kind of required. So combined UK and Ireland, we're looking at demand for 300,000 houses per, maybe 350, sorry, combining Ireland and the UK. We're both kind of achieving about 50% of that. And I was thinking about bricks. How many do we use? What ends up on site, and who lays them? And the figures are staggering. It's 2.5 billion bricks per annum in the UK. They're importing about a fifth of that, and there's a shortage of 20,000 bricklayers. You know, they're serious numbers and something that, you know, probably won't get fixed. And, you know, that brings us back to different methods of construction to reduce those numbers. And, you know, you've got the related carbon footprint issues with that volume of brick. You know, we're probably talking 2/3 of the carbon impact with a timber frame house compared to masonry.
I think a big part of that as well, the brick side of it, as simple as it sounds in the UK, especially in the past few weeks, it's done nothing but rain. You know, the predictability of a program from a timber frame perspective allows for sort of confidence from a developer's point of view, and they know when they'll be on site, they know when they'll be off site. Whereas your masonry constructions, where it's bricks and blocks, you can have weeks and weeks of no progress whatsoever. So, you know, you've got the shortfall of bricklayers, but you've also got the sort of being held to ransom by the great British weather.
Do you find many issues, Lawrence, with your tolerances not being met on the slab? Is that an issue for you much? Do you come up against that? Or
you can very much tell straight away when you turn up whether or not it's going to be any good. We have had projects in the past where the survey that we do allows for the customer to have that little bit of flexibility when it comes to whatever substructure has been created. You know, if the substructure was created and it was 50 mil smaller than was designed, we can adapt our design to then suit that substructure if the client so wishes. But ultimately, at that stage, if the client is adamant that they want it as per the design, it gives them that chance then to rectify the substructure, rather than turning up with a timber frame 6 weeks later to find that it doesn't fit. You know, you're fighting a constant battle. You are finding with the technology that's available, the sort of quality that's being produced is getting there, it's getting higher. Ultimately, you are still reliant on generally a bricklayer, a ground worker being able to produce a good quality product. So yeah, it is improving the technology, you know, with laser levels and things that are there now, and EDMs to set things out. There's no doubt about it. It is helping to get that tolerance down and get it to more where it needs to be. But like I say, the survey that we go on.
Could I ask about skills? It's been identified in the UK that there's a requirement for different skills in the offsite factories that are popping up here, there, and everywhere. Do you guys? Who are you recruiting? Are you looking for traditional construction skills, or are you able to offer opportunities for people with perhaps a different skills base in your factory?
In the factory itself, we tend to keep everything, rather than having the panels sat in one space for any length of time. I looked at it very much similar to a car being manufactured. It's constantly moving, and everybody's got their own small task, and small elements being bolted onto it as it goes along the line. So it means that, you know, you're able to, instead of having to have one person with a multitude and a range of skills, you're able to keep it where that person can focus on what their task is and become very efficient at that. And that seems to work quite well. You know, same as in the car industry, it's very similar.
Mike, or Lawrence, I was curious to see what you think the potential is for uptake with, let's say, a move to ventilated facades, so without a brick or a block to the exterior, and what the kind of what you've seen as the, let's say, the issues on site, or acceptance, or building control, that kind of thing. You know, what do you see as the obstacles?
I think it's a lot of the time people want to see brick, block, or render. To have any type of house to have a cladding externally, I think people's perceptions is they see brick as being solid, and solid meaning longevity. So there's a return to investment there. They know that it's going to last. I think there is more and more projects now coming through who are embracing different cladding systems. And I don't think there's much of a concern with building control or warranty providers, as long as the detailing's there. I think it comes across well. And I think, to be honest, they probably embrace it because it's a little bit different. You know, it's not the same issues that they're coming across every day.
Yeah, I think there needs to be generally needs to be a shift towards greater acceptance of new cladding solutions. You know, it's slightly counterintuitive to have a really efficient, you know, quickly assembled airtight, weathertight shell, and then a sort of, you know, snail's pace brick exterior being erected up the outside of it. It just doesn't make sense. I think there's an acknowledged, you know, need for people or planners who need to see bricks. That needs to be new brick systems that are more compatible with timber frame or offsite manufactured systems, not the traditional. It just doesn't make sense.
Yeah,
Can I move the conversation on a bit to optimization? Because actually, even this week, I've been working on a project with PH15, a timber frame system, and I mentioned before about Macar up in Scotland in the Scottish Highlands. And so much of what they do seems to be improving the product. And they came from more having timber as a resource where they started out. So they were quite sustainable, but then came into the passive house world when one day a client said, oh, I really want to build a passive house. And they went, you are joking, aren't you? We've got to change 75 of our key details and start all over again. So you've got to have it in the mindset to improve things and never stop, really. You know, nothing is perfect. There's always something a step further that you can go. So Lawrence, I'd be interested what your next step might be.
I mean, the system that we've got at the moment with it getting to 0.14, it works quite well at the moment, but there's always options to improve upon that and get down to a U value of say 0.1 or less. At the moment, it's finding that happy medium and that balance. You'll have customers, like you say, who want to achieve an extremely energy efficient home and get to passive house or as good as they can get. But also there's that cost side of things that people are always mindful of, and that's understandable. You could bring on a system that would be far superior to any others out there. I don't think the market is quite there yet. I mean, I've noticed a difference dealing with people for you know, projects from Ireland to projects from the UK. I would say the UK, as far as a sort of a standard is concerned, is quite a few years behind. Ireland seem to have run with it quite well, and our system over there is fairly standard. In the UK, it's seen as high spec. So I think the U value side of it is something that timber frame always allows you to have that improvement, because it's got that void there that you can change the spec of the insulation, whereas you go to a masonry cavity construction and your walls are just getting thicker and thicker to get to the same outcome.
You're on mute.
We've got a lot of questions that have come in, so I was going to hand back to you, Zach, and ask you what questions we can answer.
Absolutely. We have a lot of questions. So we'll get through as many of them as we can during this first hour. And then we, Lawrence and the co-hosts are available to extend after that hour to get to more questions. So the first question is from Courtney McCracken. Courtney, are you here still? Yeah, it looks like you are. If you wouldn't mind unmuting yourself and asking your question, that'd be great.
My question was about design. You may have answered it later. I was wondering, it looks like you have a designer prepare drawings before the client comes to you for a price.
On the design side of things, the customer would typically come to us with a set of architectural plans. It's always easier if they're in CAD format. We would then provide a quotation based on those plans. We can do it as simple as just some planning drawings with a section showing ceiling heights. So from then, the customer wouldn't really need any additional drawings. From the structural point of view, we can provide all the working drawings. That's all done in-house with our in-house designers. The only thing that we would outsource would be the engineering side of things that we then work to within our design.
Great, thanks, Lawrence. Thanks, Courtney. Okay, so next up is Thomas Harris. And Thomas, I know you had a couple of questions. Why don't you choose one now, and then we'll get back to you when your name comes up in the queue again.
Great. Thank you very much for the opportunity. Excellent presentation on the technology. And I was wondering, what's the level of variability on the choice of materials? Specifically, I've been in the spray foam industry for a long time, so favor the use of closed cell polyurethane foam as my insulation of choice. I was wondering, has any work been done at your facility to incorporate spray foam into the design and manufacturing?
We haven't as yet, purely for the fact that all of our, as was mentioned in the presentation, all of our panels have been fire tested. So we've got the certification for the panels in their current format. We haven't looked at doing a spray foam. Mineral wool seems to work quite well for us, and like I say, with the U value being 0.14, it's not something we wouldn't look at in the future, but I think it would have to be a benefit in, not just a cost perspective, but from an energy perspective as well. But yeah, it's something we definitely look at. But at the moment, like I say, we've got the fire testing for the panels in their current format, so we're sticking where we are with that one.
Great, thank you.
Great, thanks, Thomas, and we'll come back to you in a little bit. Okay, so next up is Liam, and Liam is not able to unmute, so I'm going to ask the question, and that is the manufacturing video available to show to clients? Would make explaining the process to clients who have been told that you can't work with timber frame in the southwest of Ireland. I guess it would make the case that that's not the case. And he says it's hard to change their mindset down here.
Yeah, we actually, that video has only just been put together, so it's something we will be using, to showcase to clients. I think the CGI of the panel is something that I've already used in the past few weeks, and it does come across quite well. They're able to understand the panel a bit better and understand what's included. Obviously, because every timber frame company does things slightly differently, so it's quite key to be able to show exactly what it is that they're getting when we put the quote together, because the quotation can sometimes be a bit too technical, whereas physically seeing a panel, or like you say, seeing the video with the panels going together, can be a lot easier for people to understand. But yeah, the video is something that we will be using from a marketing point of view for everybody to see, really.
Great, thank you. Okay, so up next is Deirdre Meager.
Yeah, hi, I was just wondering, is a design for disassembly built into the manufacture of the timber frame?
The way the panels are all assembled on site, they're all screwed together. So it's not something we design into it, but it would be something that would be easily dismantled. It would basically be the complete reverse of the assembly process, with all the floor cassettes being lifted in sections. Again, it's screwed into place, so we're able to literally unscrew it and move it. So yeah, it's not specifically designed in, but the way that it's constructed allows for that anyway.
Right, okay.
And Deirdre, you also had a question about offcuts.
Oh yeah, I was just wondering, obviously there are going to be offcuts, so I was just wondering, were they capable of being reused in other parts of a building?
All the machinery that we use separates sawdust from the offcuts. So all the sawdust gets sent off, and also the offcuts themselves, if they are of a size that can be used, they will be used to basically put back into the timber frames themselves in way of noggins and other pieces of timber. Any offcuts that aren't used, I'm not 100% sure what happens with them, but I would have imagined it's some sort of recycling to further use the product. But yeah, it's separated so that it's as recyclable as possible. Or
possibly reused.
Yeah.
Can be sent to some place where it can be used. Do you look for places where it could be reused, or offcuts could be reused?
Honest answer, I'm not 100% sure, but I can find out and let you know.
I think the big thing is the reduction in waste in offsite manufacturing is pretty significant. So I know that most factories' process is optimized to reduce that, so it becomes a very small volume.
Great, thank you. Thanks, Deirdre. Okay, so next up is Dara McGowan. Looks like Dara's not here. So the question was, what level of air tightness is typically achieved?
Our products tend to range from, I think the lowest we've achieved is 0.06. But as a rule of thumb, we're not finding anything above 3. Quite typically on site, we're anything from sort of 1 to 2 air changes per hour.
Fantastic. Okay, so Eugene McMahon, you're up next. Eugene, I see you in the queue or in the participants list. Give you another moment, and then maybe I'll ask it for you. Okay, so Eugene's question is, for services installed on site, how is the air tightness ensured? Who checks for this? So another air tightness question.
The reason we fit the air tightness membrane in the factory and fit a 35 mil service pattern is purely for that reason, so that electrician and plumber aren't needing to get anywhere near to the airtight membrane. And also it just ensures that you've got one continuous layer. So from the ground floor panels to the first floor panels, the airtight membrane's fixed on the outside of the joist cassette. So those two are then connected, so you've got one complete layer of air tightness on the site. If it's a self-builder, we would leave the ceiling on the top floor to them to fit. If it was something that we were doing more on the site, we would potentially go back and fit the air tightness membrane to the top floor ceiling. So you've then got that complete layer.
Excellent. Okay, so Thomas Harris, you're back.
Yes, thank you very much. Just a question regarding the background and the data sets for these claims that are made, the 70% reduction in on-site repair, that sort of thing, the speed claims that are made. I'm from the US and I work in the US and Canada here, and we have a problem when we make claims. We have to justify them and back them up with data and whatnot. I was wondering if you have any or can share any of the data that support the claims in general for this type of construction, as well as the company specifically. Thank you.
I think that question might have been some of the things I mentioned, Thomas. I happily share the reports or some reports to you on that. You don't get time to get into the justification in a short comment here, but yeah, gladly, if you leave your contact details, I'll send them over to you.
Wonderful. Thank you so much.
You're welcome.
Great. Thanks, Thomas. Thanks, Hugh. Okay, next up is Daniel Coyle. Okay, got it. Can't unmute. So Daniel's question: has the timber frame buildup / system been fully assessed for moisture risk, interstitial condensation, i.e. dynamic hygrothermal modeling using WUFI or similar? Does the OSB board on external face introduce a risk of trading moisture within system?
That's probably one for me, Lawrence, given that
definitely one for you, that one too.
Yeah, I did the WUFI analysis on this wall buildup, so yeah, they would all be tested and safe. Probably the question is, interesting. Does the outer board? In this case, it doesn't. It's quite vapor tight internally, vapor open externally. You do reduce the moisture content if you use a different exterior board, but the OSB in this buildup is safe.
Great, thank you. Okay, so where are we? Steve Coe.
Good morning. My question is about scale. What size projects have you been able to do, and are they affordable for a affordable housing solution?
This year alone in Ireland, we've done 720 units. Next year is probably going to be just over 1,000. That's something we are looking at increasing in the next couple of years. Probably get something like 2,000 units a year. The UK is a bit different. We are much more focused on one-off self-builder bespoke developments, maybe getting up to 10 or 15 units on a site. So not quite the same market as in Ireland, but certainly from a scale point of view, it allows for that scalability, which I think Hugh's touched on a few times, that with the issues that masonry construction has and other construction methods have, having it off-site and under the sort of a timber frame envelope, if you will, I think that allows for that scalability and keeps the cost down as well quite considerably.
Great, thanks, Steve. Next is Brad Durant. I know you had a couple, Brad. If you start with one of them, we can come back to you. I didn't check the participants list to see if Brad was here, and he's not. So I'll ask the question. Oops. So let me grab it. This is embodied energy is lower in cellulose. Have you used it? And your membranes look like they have aluminum foil. Does this not cause problems for wall getting condensation?
Do you want to get that one here?
Yeah, sure. I guess the walls are quite well tested, like we kind of touched on there, using WUFI 2D analysis. So it's a metallic film that's used, but very specific SD or perm values to facilitate drying of the wall, and that side of things is certainly okay. As to why everyone isn't using more cellulose, I don't know, but probably scale and installation, factory setup might make it more challenging at that kind of volume. But yeah, not my decision. I'd say probably for you, Lawrence, that.
Yeah, I think like you say, it's the installation of it. We've looked at it in the past, we've been asked, but I think from a productivity point of view, it's a lot more labor intensive, which obviously just drives up cost.
Great, thank you. So we do have more questions in the queue, but we're gonna I think pause and have a moment for the co-host to share some thoughts before we get to the end of the hour. We'll kind of close up that end of the hour and then extend on. So Mike, do you want to just start with that?
Yeah, sure. It's interesting to hear the questions about moisture in particular, and of course, these things have to be assessed. But again, it comes back to what we spoke about last episode with Thomas. It's all about the installation, quality of the connections on site. So I guess my follow-up question, I suppose, would be, Lawrence. What's your process for kind of overseeing site installs to ensure the continuity of those cassettes, those panels as they come together, is consistent with the simulation that Hugh's doing?
What we tend to do is at the end of each project, we'll carry out a sign-off procedure. So once the project is finished, we'll go down to site, make sure, very much what I used to do earlier in my career, make sure that the kit has been assembled correctly. If there's anything that's not quite right, it's at that point any remedial work can be carried out. Just so that we've got that continuity and the standards are kept as high as possible. But with the systems that we have in place in the factory and the quality control, that tends to alleviate 90–95% of any issues you're going to have. There's always going to be things that happen on site, but it's how you deal with it that's the main thing. I guess ultimately, somebody has got to be prepared to pay for in situ monitoring. It's the only way to really know long term, isn't it? Yeah. It's a lot of it's down to the training of the guys putting it together on site as well. They've got to buy into how important each element is, not just smashing together a timber frame. They've got to treat it like their own home. And ultimately, when you can trust the guys on site, that's a huge part of the whole process. Last thing you want to do is for it to fall at the last hurdle. Yeah.
And I just say it was a really great video that you showed us, full picture of exactly how the process works and combined with the presentation, Lawrence. So I really enjoyed that. Just one final point on sustainability. So say, for example, the PIR insulation that you used in there. Is there a possibility that that might be changed in future? You know, what's the reason for that? This may be a Hugh question, but he's up next anyway, so you might be able to answer that. Or is a lot of it driven by the clients? You know, that was one of the things that intrigued me. You said that range of airtightness. Can you push them to go more airtight?
Something that the PIR board is something that I think it's not an easy way to prevent cold bridging, but it seems to be very much a go-to method. It provides a solid structure for a service batten to be sitting on. There is other products out there, but I think from a labour point of view in the factory, it's easy to work with. It's quite reliable. Hugh can probably touch on the sort of energy side of things on that one. But what was the second part of your question there, then?
Second question, just about the clients. You know, I'm intrigued by that range of figures that you were getting for some of your buildings.
Yeah, you do. Your clients can vary quite dramatically. It's something that your self-builder is very key. They're very keen on it. They're wanting to be as efficient as possible. And I think by being able to give them that reassurance that the systems are done in the factory under controlled conditions, puts their mind at rest. If they were reliant on it being done on site, it's quite a worrying time for them, to be fair, because they're reliant on somebody on site, and they've got to, like you say, either be overseeing them permanently to make sure that it's done, or do it themselves, which ultimately some clients do try to do as much as they can themselves, but from a cost perspective, it can take quite a lot longer to do the project, whereas being able to do it in the factory with the right equipment and the right conditions, it speeds the process up. They get the quality they're after, and they know that it's done in a controlled manner. So yeah, having customers come around the factory and physically see it is something that puts their mind at rest as far as what the product is that they're getting.
Hugh.
Yeah, cheers. No, I guess, look, from my side, I just want to thank Lawrence and the team at KTF. It's, you know, really open kind of presentation, and I hope it'll kind of, I suppose, inspire other people to, you know, be more, see what's possible to move towards offsite construction, but probably also the customers, that people can accept and see that something factory produced to that kind of level of precision is quite different from what we've seen in the past. So yeah, I'm obviously a fan of I suppose what you do in the offsite construction. So yeah, more of that kind of thing. And I know the questions about the PIR are, I suppose, real and probably something we'll need to address, and we need more of a focus on embodied carbon to probably help to, I suppose, regulate that side of things. And, you know, we're definitely not there yet. There'll be a few more steps before with improvements. And like you mentioned earlier on, you're always looking at improvements, and yeah, hopefully the regulatory side of things continues to push that.
Can I just touch on what Ben had said there again? I think a big part, as far as the air tightness is concerned, is the education to the customer, that it isn't just one element of the build that's important. The interaction between the windows and the timber frame itself is quite key. The type of windows and doors that they install, and making sure that the follow-on trades are aware of how important that airtight membrane can be. You'd be surprised how many times electricians and plumbers cut a hole in it because it's easier for them, without really understanding how important that product is. So I think part of it is education as well. Obviously, they're not new tech, they're not a new system, if you will, but to a lot of people it's new technology. So it's educating people as to how to use it to get the most out of it.
Fantastic. Thanks, Lawrence. Thanks, Hugh, Ben, and Mike. And I just have a couple of announcements to make, and then we're going to dive back into the questions and answers. There's still a good list of questions coming up. First, I want to start by saying that everything we do here at the Passive House Accelerator comes thanks to support from our sponsors. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minitair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Thank you too to our champion sponsors, Icon Windows and Doors and SIGA, and our stakeholder partner, NYSERDA, or the New York State Energy Research and Development Authority. Also, thanks to patron sponsors, Aero Aggregates, Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So a big thank you to our sponsors. On the Passive House podcast, we have an interview right now with John Tallis and Julia Thomas of our Fab House. So we're continuing the conversation around offsite construction. John and Julia are based in Australia, and they talk about their process around prefab Passive House. And these are prefab units or pieces that are built in Europe and shipped to Western Australia. So it's a really interesting kind of challenges and conversation with Matthew Cutler Welsh, the co-host of the podcast. We're also doing a whole bunch of short bonus episodes that come from my interviews when we were at the FIASCon 2021 conference, excuse me, in Tarrytown, New York last month. And those are brought to you by Rockwell North America. And the most recent of those interviews is an interview with Todd Kimmel of Rockwell North America. So please check that out on the Passive House podcast. I think we were at Florence Shields, if Florence is still here. Yeah, Florence, you're up.
Hello. I was just wondering, can you hear me?
Yep.
Yes.
Yeah, I was wondering whether the current situation with COVID and Brexit and so on, how that affects, how delivery delays affect your lead-in time for projects.
Well, at the moment, we're happy to announce it hasn't really had an impact currently. We had a project in Sheffield that came across back in August, came across no problems at all. We obviously had to get a few things in place with commodity codes for the product itself. But other than that, it was pretty smooth sailing, to be fair. The lead-in times with timber did fluctuate quite a bit with lockdowns and COVID. That had quite a big impact on it. I think that was felt pretty much across every industry, to be perfectly honest. But they seem to be, the availability seems to have settled back down now. Costs are something that are coming back down. Certain elements are slower than others to come back down, but they are coming back down to roughly where they were pre-COVID.
Thank you.
Great, thanks, Florence. So next up is Colm Mahoney. Colm, I see you there on the list. Are you able to unmute yourself? Okay, I will ask Colm's question. So what are the typical U values for the building envelope and also the air tightness level? We already discussed that, and heat loss indicator achieved. So typical U values and heat loss indicator achieved. The
typical U value is a 0.14. Air tightness, like we'd said, it's anything from sort of 0.06 up to 3 is what we're finding as the range, but it can depend on a lot of factors. The building itself can affect that, the size of the building and such. As far as the heat loss indicators, I don't know if you might know a little bit more on that one, possibly.
On the heat loss calculations, I think suppose every project is individual, and I see there's a few questions kind of about BERs and things like that. So it's an overall energy calculation for each individual dwelling. I know the industry have prepared standardized thermal bridging details so that it's possible to calculate, using those standard details to get very accurate outputs for everything of the building as a whole. So there's a target within that to avoid any localized thermal bridges, but also to have an idea of how the house overall is working.
Great, thank you. It looks like Eugene McMahon has left the call. So Patricia Partridge, you had a question.
Yes. Hi, Hugh. That was very interesting presentation, the video especially. So what I'm understanding is that you have the wood frame to support the roof and the floors, obviously, but that you want to use the PAR insulation, but you might as well fill the wood frame with the regular, I should say, isn't the right question, but insulation. So I appreciate the other questions because I think you really answered mine, but I did want to clarify. So therefore it's vapor open to the outside. That's how you keep the condensation out of the outside frame.
Yeah, the exterior membrane is extremely vapor open, so that will facilitate drying to the exterior.
Great, Patricia, that you said. So we have, let's see, up next, Thomas, did you get a chance to ask all your questions? I'm seeing at least one more.
No, actually, they've been answered. Thank you very much for the opportunity.
Okay, great, fantastic. So I'm just searching to see who's here. Liam Kelleher.
Yeah, can you hear me?
Yes.
Yeah, I mean, I was just interested in, because when I've seen any houses of timber here in Andalusia, where I am, they've normally been isolated houses. They've not been built in between buildings in an urban environment. Now here we have a very high requirement for fire resistance on the terrace wall of what we call intra-medianeras, and that's about 2 hours. So have you done any, sort of infill projects in an urban situation?
A lot of the projects that we've been involved in are housing developments. So the proximity of house to house is done in such a way that the fire mitigation isn't an issue. We've quoted for projects in the past, and they've specified certain mitigations to prevent any fire transit from one property to another, but it's not something we've got involved in an awful lot of. It tends to be more project specific, but it's not something that we've actually got involved in a great deal, to be honest.
Okay, yeah. I mean, as I just said, I was speaking with a number of people that were actually doing not so much prefabricated down here in southern Spain. It's something that doesn't normally get happening in Andalusia. We don't have many trees, so anything normally has to come from Norway. But it was, I know they have done something similar in Barcelona, where they have greater access to trees and they have the same sort of problems. But it was looking to see how, if you had dealt with that. But okay, fine, thanks.
Great, thank you, Liam. Next up, we have Barbara Landstreet. Looks like Barbara just left. So then we have Joao Ferreira. Joao, I see you. Are you able to unmute? Okay, I will ask Joao's question. Why going to timber frame and no CLT?
Timber frame something. So are they asking why we don't use CLT more in our system, or?
I believe so. Yeah. Why? Right.
Probably due to cost, to be perfectly honest, and it's something that our system's already set up, and it works quite well with the, like I say, with the thermal side of things, and the fire testing. We've already got that all set up, so our system works quite well. We do use glulam every so often when the design stipulates it. You know, with that curved roof, for example, we're using glulams in there, but the cross laminated timbers isn't something that we get into a great deal, to be honest.
Oh, CLT is cross-laminated timber, Eugene. Okay, next up, Courtney McCracken. Courtney, I see you there. All right, I'm gonna ask, you're unmuted, great.
Yeah, sorry. As I said there, when moisture gets into the wall, it's rather when than if. Can it escape? I think you answered the question by saying that the exterior material is vapor open. I did want to, just an interesting point, when I saw that this presentation was about timber frame, in the US, to me anyway, timber frame is large timbers. But am I right that timber frame in Ireland is apparently really wood studs, as we would call them, wood, just framing lumber.
Yeah, timber frame, our sort of interpretation of timber frame is like I say, a 38 millimeter by 140 millimeter structural stud, constructed into a skeleton, I suppose you'd call it, and then sheathed with an OSB on the outside. The only difference from an open panel to ours is the insulation side of things, and the airtight membrane and service patterns being factory fitted.
Great, thank you, and a great presentation. I wish you all the luck. I hope you do well.
Thank you.
Thanks, Courtney. Okay, next up is Stephen Howland, and Stephen is not able to unmute. So his question is, I would like to ask, is it easy to upgrade the fabric in a future date? For example, if in 5 or 10 years time, I wanted to improve the insulation of the wall, can I put on external wall insulation, etc.?
Probably one from I think it's the condensation side of things. If you start insulating on the external, you're preventing that open moisture side of things that Hugh was touching on before. Whether you want to sort of touch on that one, Hugh?
Yeah, I guess it's not really that practical, I think, to upgrade an offsite constructed timber frame at a later date. And if that's kind of your consideration, you're probably as well off just to increase the U values during construction. Your standard is 0.14 and you can go to 0.1, and lots of people can. So it's infinitely cheaper to do it at the time of construction. So really at those kind of U values, the need to upgrade really shouldn't exist.
Great, thank you. So we had Manny, you have a question? Manny Gruwall.
Yeah, my question was like, for this kind of envelope for a typical single family home, 2,000 square feet, what will be the envelope cost average square feet?
The cost per square foot can vary quite dramatically depending on the design, what structural implications are involved. If there's any steel required for portal frames, things like that, that can add quite a bit of cost to the project. We've done projects where they're working on in pounds. It's anything from sort of £19 a square foot up to £45 a square foot. So it can vary quite dramatically. The larger the property, the cheaper it becomes, because ultimately you've still only got one amount of design, one set of structural calculations. So yeah, the larger and simpler the design, the cost is coming down.
Thank you.
Great. We have an important kind of imperial versus metric question from Courtney about whether U 0.14 is R7 and is the European system different. So I believe that to do the conversion, you multiply by 5. So it'd be 7 times 5. Does that sound right?
Hugh might be the best one on that one when it comes to the differences between the two.
That's my understanding. I think that translates to an R35 for.
That sounds
imperial.
right, Zach.
Yeah. This just came up on the podcast, so Matthew and I were puzzling through it. Great. Well, we've gotten through our questions. Co-host, do you have anything else you'd like to add before we close up? If not,
I just wanted to ask Lawrence if you guys have got any intention of starting to incorporate elements of building services integration, first fix, cables or pipes or anything of that nature into your wall cassettes, or is that something that you want to stay well away from?
I think if we were going to branch out into anything, it would be offering what I would class as a wind and watertight system, where we would potentially look at doing substructures using something like a core system where it's an insulated slab, and allowing and installing external windows and doors and a roof covering, so that when we get there's nothing. When we leave, they've got a wind and watertight structure. I think getting into the internal services is you're getting almost towards a turnkey package, which I think is a different thing altogether. I mean, at the moment, we're quite happy to stick with this sort of system that we put together, just because there's that many different options when it comes to things like windows and doors that it's very difficult to price for the actual options that people are looking for.
It's really great to hear your outputs and your growth plans as well. It's really exciting time for you guys. Thanks for putting the presentation together.
We had another question. Margaret, are you available to ask it? So Margaret's question is, how do Keenan timber frames compare with SIPs? And I think that and then she says need lowest cold bridging. So that maybe she needs the lowest cold bridging. I'm not sure.
I've not done any direct comparisons between the two. I think it's something that people do look at one or the other. There's not many. I've not come across many who would sort of entertain looking at both. From a U value perspective, I think SIPs is something there's maybe a little bit more flexibility there from a U value. But I think from a structural point of view, I think timber frame as something that maybe has them on the ropes, really. I'm hoping anyway.
Great, thank you. So Ben or Hugh, do you have any final thoughts before we close up?
No, I'm all good. Over to you, Ben, I'd say.
Yeah, good here. I think we've covered a lot of ground. And again, yeah, very interesting. Thank you, Lawrence.
No worries.
Be well, everyone, and see you soon.
Thanks very much.
Cheers, guys.